Hi viewers. Welcome to this presentation on power system frequency. Power system frequency depends on load generation balance in the system. This general statement is known to power engineers but not clear about parameter. Frequency do not depend on energy generated and consumed by the load. Frequency is indicative parameter for any instance, whereas energy is integrating parameter for some period. However, current in circuit depends on apparent power flow. Voltage level depends on reactive power balance at node. Frequency depends on active power balance in the system. So now talk is about active power because discussion is for frequency. Actual criterion for load generation balance is active power injected in the system. Generating plant requires auxiliary power for self-use. Proportion of auxiliary power required is different according to types of plants like thermal, hydro, gas, nuclear, etc. Also auxiliary power not required when under outage. Therefore, generation in the statement means active power injected in the system is equal to power generated minus auxiliary consumption. Similarly, load in the statement is active power consumed from the system. Power consumed by users is consumers' demand, and power consumed by system network is T&D losses. So total power consumed from system is equal to consumers' demand plus T&D losses. Frequency changes due to unbalance of power injected and power consumed. Unbalanced power is equal to power injected minus power consumed. This is active power weighing scale. Left side pan has power injected in the system. Right side pan has power consumed from the system. Pointer is indicator for frequency. When power injected is equal to power consumed means unbalanced power is 0. Both the pans are at same level with arm horizontal and pointer towards normal frequency. When power injected is higher than power consumed means unbalanced power is positive. Left side pan is down and right side pan is up and pointer towards high frequency. When power consumed is higher than power injected means unbalanced power is negative. Left side pan is up and right side pan is down and pointer towards low frequency. Frequency deviation is controlled by system bias and system inertia. Frequency deviation, drop or rise, depends on system bias. System bias is power required to change frequency by 1 Hz. Bias is system specific and is about 3 to 4% of the system demand depending upon load mix. Frequency deviation is equal to unbalanced power divided by system bias. And operating frequency is equal to nominal frequency plus or minus frequency deviation. Review of kinetics. In case of linear motion, velocity is equal to distance divided by time, means v is equal to delta s delta t. Acceleration is equal to rate of change of velocity, means a is equal to delta v delta t. Force is equal to mass times acceleration, means m times delta v delta t. Similarly, in rotary motion, angular velocity is equal to angle divided by time, means omega is equal to delta theta delta t. Angular acceleration is equal to rate of change of angular velocity, means, is equal to delta omega delta t. Torque is equal to moment of inertia times angular acceleration, means T is equal to I times delta omega delta T. Similarly in electricity, frequency is angular velocity. Unbalanced power is the force that changes frequency. Therefore, unbalanced power is equal to system inertia times rate of change of frequency. Ultimately, rate of change of frequency is equal to unbalanced power divided by system inertia. This means rate of change of frequency depend on system inertia. System inertia is moment of inertia of all rotating machines in the system. This includes turbine and generator of thermal, hydro, gas, nuclear type rotating power plants. But static source like PV plant have no inertia. It also includes rotating machines of loads in the system like motors, etc. But static device like transformer, heaters, lighting devices, etc. have no inertia. Now let us observe effect of unbalanced power, system bias and system inertia on frequency variations. Three factors influence frequency variation. 1. Unbalanced power forces frequency deviation. 2. System bias and system inertia controls frequency deviation. This is chart of frequency against time, is showing frequency variations under different conditions. 4 parameters: system frequency, unbalanced power, system bias and system inertia is as shown. Now let operating frequency is 50.00 Hz. Frequency is stable as unbalanced power is 0. Frequency rises when unbalanced power is positive, that means power injected is more than power drawn. Frequency rise depends on surplus power injection. More is the surplus, more is the frequency rise. Effect of system inertia. System inertia controls the rate of change of frequency. So higher the system inertia, the frequency drop is slower. Therefore, power system is more stable and safe with large system bias and higher inertia. Frequency variation may be smaller and slower, allows time for corrective actions. Routine frequency drop or rise due to load or generation rise or drop is controlled by system operator. Generation is adjusted when feasible, else load shading is done. However, sometime when operators' corrective action fall short or delayed or frequency change is fast, frequency may deviate to unsafe range. Generators are automatically isolated to avoid damage. System may collapse due to cascading when frequency is already low. Automatic load suppression scheme using under-frequency relay is provided as backup protection to avoid the blackout. This load relief arrests dropping frequency and saves system from collapse. But this arrangement is like trap to lock the vehicle moving toward edge of the land and falling in valley as in picture. This trap is effective when vehicle is moving at moderate speed. But vehicle jump over the trap due to momentum when moving very fast. Similarly, under-frequency load suppression scheme may not be effective to arrest dropping frequency when frequency is dropping very fast due to low inertia and or huge loss of generation. Agriculture pump set is motor load. These are not in use during the monsoon. Industrial load is predominantly motor load. This is also not working on holidays. Therefore, system inertia may be low and frequency drop due to loss of generation may be faster than normal during industrial holidays in monsoon. Request: please like, subscribe and recommend others if found worthy. Viewers' comments welcome. Thank you, viewers. Bye until meet again in next episode.